Hello, and welcome to the Pint of Science podcast. I'm your host, Matthew Davidson. I'm a freelance science communicator and a Pint of Science organizer. Today we are coming to you from the amazing studio at House of Nerds in Volkan in Oslo. And today I have two very exciting guests. Before we begin, Pint of Science is a global communication festival. We bring you 3 nights of stories of extraordinary science with topics like energy, health, and climate. This year in Norway, we will be hosting the festival May 22nd, 23rd, and 24th throughout Norway. We have locations in Oslo, Stavanger, Trondheim, Bergen, and Tromsø. And we have all these exciting stories. And right now, while we wait for the Pint of Science Festival to happen, we are bringing you this podcast. So today, I have with us Aditi Bhatnagar, who is a PhD student at the Rosalind Center for Solar Physics at the University of Oslo, who is going to tell us about solar physics and the aurora. And I also have Monica Trondrød, who is a postdoc researcher at the Norwegian University of Life Science, who's going to be talking about the reindeer who live in Svalbard and how climate change is messing with their adaptations. So I want to start with Monica. And my first question for you is, what are reindeer even doing in Svalbard? It's not close to anything. Did they swim? Like, how did they even get there?
That is a great question. But so during the last ice age, most of the Arctic Ocean was covered in ice. And there's a lot of genetic studies on reindeer showing that Svalbard reindeer are most closely related to reindeer that you now find in northern Russia, Siberia, especially in Novaya Zemlya, which is this group of islands right north of mainland Russia. And they most likely just wandered from there across the ice until they found Svalbard. And for some reason, they settled there.
Okay, and then they got stuck when the ice left.
Well, that's what we think,
Okay.
because then, yeah, they stayed there and then evolved to be very well adapted to the Svalbard climate.
Okay, so your research is on those adaptations,
Yeah.
right? So what is it? What kind of adaptations do they have? I mean, obviously they're good at being in the cold, but what is it that makes them good at being in the cold?
So reindeer in general are really well adapted to being in the cold. They are an Arctic species, but you find them all across the Arctic, and they all have these general adaptations that are the same or similar across all reindeer. For example, they have incredibly thick fur. They have some really cool structures in their nose and brain that cools down the air when they breathe in, so that it heats the air when they breathe in, so that the air doesn't cool their brain too much, so they don't lose too much energy from the cold air. And when they breathe out, they do the same. So they have these really cool ways of protecting themselves from losing heat in the winter. They also have these really cool adaptations in their legs so that their blood vessels are connected or very close to each other. So the blood that comes down to their feet is warm. It's being cooled by the blood that's coming up from their feet, so that the blood that's actually in the bottom of their feet is really cold. So then they're not losing heat to the ground. So they have super cold feet. And this is a cool adaptation because essentially it makes up a bunch of strategies to reduce heat loss, essentially, which makes them really well adapted to cold environments. And another thing that Svalbard reindeer have evolved in addition to that is that they have short legs and short noses and a really fat trunk. So they are these sort of dwarfed reindeer. And that makes them even less susceptible to losing heat to their environment. And they also have the thickest fur that we've seen in reindeer. So they have twice as long fur, and it's even better at protecting them from the wind, for example. And I can go into more details, but yeah.
For sure. Well, that's some really good adaptations, it sounds like. I mean, are there other animals in Svalbard that have similar adaptations, or is it this unique to reindeer?
So this process of cooling down the blood to the legs, for example, that's common in a lot of birds as well, especially seabirds, because seabirds are often in the water, right? So they are constantly exposed to cold,
right, or just
cold
standing
water,
on the ice.
Standing on water or in water. So they have the same adaptation in their legs. A lot of mammals have it as well, other mammals than reindeer. We know that wolves have it. I'm pretty sure dogs have it too. So Svalbard, the fox that lives in Svalbard, the Arctic fox, has it. And the ptarmigan might have it, but I'm not too familiar with that type of bird compared to seabirds. But I know seabirds do it as well.
Okay. Are there a lot of reindeer? I mean, my understanding of Svalbard, I know it's like super far north. I remember reading about armored polar bears and when I was little, but it's not that big a space, right? Are there a lot of reindeer there, or a lot of different animals?
There are, well, animals define animals, because there's a lot of insects, actually, and insects and invertebrates and small animals. But for the large animals, there's only 4 resident terrestrial animals, so animals that live on land and not in water. And you have the reindeer, the Svalbard rock ptarmigan, which is a specially evolved rock ptarmigan that lives in Svalbard.
That's a bird, right?
It's a bird.
Ptarmigan?
It's
Okay.
a bird, yeah. It's closely related to grouse.
Okay.
Yeah. And then you have the Arctic fox, and then you also have an introduced species called I think it's a vole, and I don't remember the English word at the moment, so I apologize for that. And that's introduced, but accidentally.
Sure.
So those are actually the only 4 large or resident large animals that you have in Svalbard. And reindeer, the latest estimates of the total Svalbard reindeer population is around 22,000 individuals-ish.
Is this more than the humans there?
Yes, for sure. So the population of humans in Svalbard is around, of human residents and permanent residents in Svalbard is around 2,500 people.
Okay.
So there's even more polar bears in Svalbard than humans, and there are, well, almost 10 times as many reindeer. So, well.
Wow. And so what are these reindeer you said are not they're not domesticated, right? So they just wander around. Are they hunted? Or are they, any?
Yeah, they were hunted intensively, actually, until the early 1900s. Because, typically when people arrive to new areas and they see that there are animals that are susceptible to being hunted and harvested, they are normally over-harvested, right? And this happened to the reindeer as well. They were almost going extinct until they were protected. And now there is a very limited regulated hunt for permanent residents in Svalbard. So you can, if you lived in Svalbard for a certain amount of time, you can apply to hunt reindeer. Yeah.
Okay, so your research is not just on what these adaptations are, but like how climate is affecting them. So I imagine as things get warmer, being super protected against the cold is not going to be as helpful.
Yeah, so I have a background in physiology, and then I work mainly on the physiological limitations for reindeer in a warming climate, but we've also seen a lot of ecological adaptations, right, or changes. So what we've seen, even though while it's getting warmer, we do actually see now that because it's getting warmer, there's more vegetation available for the reindeer to eat. So they can get fatter prior to winter, and then they actually survive better. So the populations are increasing now with climate change, and we still don't know exactly why, and we don't know how long this will benefit the reindeer, because at some point, as you mentioned, they are adapted to cold environments, and we see that they typically avoid or they change their behavior when when the air temperature gets too hot. So around 12 degrees Celsius, which you can imagine is quite cold for us, that's when you see changes in their behavior in reindeer. So they start to seek cool patches, and they start to try to cool their body down. So as it's getting warmer and warmer and warmer, they might actually be more exposed to this heat stress, which might be bad for them since they're adapted to staying warm.
Mm-hmm.
Yeah.
But so how much is Svalbard changing with climate change? I mean, it's still very far north, right? And then in the winters, I imagine it's extremely cold and dark. And in the summers, is it that much warmer? So how much has the temperature really changed? In recent history,
it's changed. It's actually the place on Earth that has the most extreme temperature increase due to climate change.
Wow.
So
why is that?
So there's this thing called Arctic amplification, which is probably climate physicists and climate researchers are better at explaining that. But essentially, areas towards the poles, and especially in the Arctic, are warming 4 times as fast as the rest of the world. And Svalbard is at the epicenter of that increased warming rate. So in Svalbard, temperatures are much more or the sort of temperature anomalies are much more extreme there than elsewhere. This year, actually, January was the warmest January in 100 years. And the temperature was, the average for the whole of January was 9 degrees warmer than normal. Yeah.
Sorry for that pause. Our lights just turned on for some reason. So that seems like it would be, it seems like it'd be a problem. Is that special, like these kind of changes, is that special to Svalbard, or is that sort of indicative of like some more trends going on globally?
Well, which changes? Temperature
Just
changes?
the temperature changes and these adaptation changes, these behavioral changes that the reindeer are going through.
Yeah, we do. Well, I've researched a bit on mainland reindeer as well. And we do see the same response that when it gets warm, they change their behavior. And this is something we see in a lot of mammals in general, especially ungulates, so animals that are hoofed animals. And they typically depending on what climate they're adapted to, they have sort of at some point some kind of temperature threshold where they find it too hot and they need to either change their behavior or they have to do something else, or they have to change some physiological processes to avoid becoming heat stressed. So that's a general response in animals. I mean, you could probably relate to that if you're in Spain on a super hot day that you don't want to go for a run in the middle of the day, right?
Oh yeah.
Yeah.
No, I went to Madrid this summer. It was miserably hot.
Exactly. So animals have those similar type of responses. So that's not unique to reindeer. Yeah.
Okay. So I want to introduce our other guest, Aditi, but by way of introducing her, do reindeer care about the aurora? Do you see any response when the aurora's out?
I have no idea. I haven't looked at it. But I do know that reindeer have really cool adaptations to seeing in the dark, especially Svalbard reindeer. They have this modification in the pigments of their eye. So if you take a photo of a reindeer in the midnight during like the dark season, they're actually blue. So they change so that they're more sensitive to light. So I'm pretty sure that they will see the auroras. I just don't know how they react to them.
How they respond.
Yeah.
Well, one of the really exciting things about being in Norway and being immigrants in Norway for myself is that I get to see the aurora fairly often. I got to see it from my house here in Oslo a couple weeks ago.
Nice.
Yeah. So, Aditi, can you tell us a little bit about sort of generally? We'll get to the aurora part because I know you're excited to talk about the aurora. And we're all excited to hear. But can you tell us a little bit about your research and kind of how it relates to aurora?
So I'm doing PhD in solar physics, and I am studying very small scale brightenings in the lower atmosphere of the sun. And I'm also trying to understand, do they relate to some other brightenings in some other like upper layers of the sun's atmosphere. So, but that is sort of very small scale. The part which is related to aurora actually is the large scale events which happen on the sun. So, but I like seeing the auroras. That's why I decided to sort of understand more about it, how they happen, and like just I'm always ready whenever there's a chance. I'll go out to see them.
Of course. So I was looking at your profile. You study something called quiet sun Ellerman bombs.
Yes.
Now, I was a physics major, so of course I know what those are. But for our audience, I don't actually have any idea what that is. Could you explain what that is that you study?
So they are very small scale brightenings which we see in the photosphere, and they look like small flame like structures, and they are more clearly seen when you see the sun, observe the sun towards the limb. So you have the sun at the center and towards the limb when you go towards the left or right side of the sun.
Okay, and that's like you're talking about like the surface of the sun.
Yes,
yeah?
Surface of the sun. And they were first seen with the active regions or the sunspots, so they were called element bombs. But now we are trying to study more about them in the quiet sun part, and hence they are named as quiet sun.
Okay, so
element bombs.
what is a quiet sun? I didn't know the sun was loud. Was there also a loud sun?
So you can have, like, if you see the sun, you can see various portions where you have the sunspots. Look at the sun's magnetogram. You can see many black and...
So I assume magnetogram is like how magnetic it is?
Yeah, like it shows the magnetic field measurement of the sun. And you can see many black and white patches on it on a sort of gray image of the sun. And at times there could be even black and white. These patches usually are seen together, and these are called sunspots. And sometimes they are not seen together, and they can be just the feature I'm trying to explain is called the plages. So just to sort of isolate it from the quiet sun part. The quiet sun is where you have very less activity happening on the sun. No major eruptions. So that's where you see the magnetic fields of basically the positive and negative magnetic fields, which are very small scale, and you see them sort of cancelling each other, and these flame-like structures happen where those magnetic field lines cancel each other.
Okay. And how do you look at, you said you have like, I don't imagine you have like a big what kind of like a telescope, or what sort of ways do you actually look at the sun with this to study this?
So there are few instruments in space which observe the sun continuously. But the one which I am using is actually a ground-based telescope in La Palma, Spain. Okay. And so we go there, we have like campaigns every year, like 3 campaigns every year. We go there, we observe whatever.
I like the idea of going to a telescope and looking for something specific being called a campaign.
Yes, so
we call them campaigns too.
Yeah?
Field campaigns.
Field campaigns. Yeah. I never got to go on a field campaign.
So before the campaign, we actually decide what all we have to observe, what all features of the sun we have to observe on the sun, and the observers which go then observe them, and after coming back we reduce the data and then identify which data sets we have to use for our actual research work.
Okay, so when you look at this quiet part of the sun, you see these little magnetic changes, fields.
Yes.
What do you do with that? Like, what does that tell you?
So that will explain even in smaller scale of the sun how the magnetic fields are interacting with each other, because till now, like if you have some instrument in space, and the instruments which have been, they usually don't have that resolution which can observe these small scale features. So that's why it's good to even study the small scale when you have that ability in the instrument, like it can resolve such small scale. So
okay, and then understanding the small scale structure of the sun, what does that tell us?
So, for example, the ones which I am studying, I am trying to relate them to another feature called UV bursts, which happens in an upper atmosphere of the sun. So, relating that and even more events will help in understanding how the how the magnetic field lines, when they interact, that happens over the atmosphere of the sun.
Okay, and so that that whole thing of like the magnetics, and I've seen like the big solar flares and things. That's why, I mean, I'm familiar with those pictures. They look really cool. So that's related to the aurora, right?
The bigger
those
scale,
big ones, yeah. Okay, so how does that? I've heard the term solar wind. And I only really understand it in the context of like science fiction and like spaceships flying around on solar wind. So I don't think it's quite that. What is that, and how does that affect us here with the aurora?
So the sun is emitting like continuous charged particles, which we call the solar wind. And that when reaches the Earth's poles, the charged particles interact with the atoms in the Earth's atmosphere. And then when these atoms emit photons, they release light in various colors. So it's the solar wind, it's the interaction between the solar wind and the gases in the Earth's atmosphere which is causing the
So
auroras.
the wind, and I realized I just did little air quotes, which doesn't work on a podcast, but so this wind is it's not exactly a wind, but it's the charged particles coming out of the sun. Okay.
Yes.
And so when they come to Earth and they interact with our magnetic fields, that's our different colors. Why do we only see them like up here? Why don't I see that, in like, back where I was living in like Colorado?
So when the charged particles come towards the Earth, they are usually so if you know the magnetic field structure of the Earth, then it's sort of stretched towards the night side of the Earth. So the charged particles, when they arrive, they are sent towards that part where you have the magneto tail. And there, when you have the solar wind arriving, and if for example, the speed of the solar wind increases, that will increase the field lines to interact and like stretch more there, and that releases the particles towards the poles of the Earth. So that's why when you have, for example, auroras happening, they first start happening towards the poles, and as soon as the more and more solar wind starts arriving, like the speed increases, the density of the particles coming increases, it starts propagating towards the south.
Oh.
Is that why we need really powerful solar winds to be able to see them down here?
Yes.
All right.
Yeah, I check my app all the time, like a notification, and so that's actually my next.
Which app do you use?
I use Aurora mostly, but I also just got what is it? I got this one that has a lot of technical information that I don't understand.
Which one?
There's Space Weather, which
Space
has
Weather Live.
Space Weather Live that
I love
has
this app.
real-time solar wind and
Yeah.
densities and BZNTs. So if I'm looking at this app, what do I look at? What do I look for if I'm like excited to see the Northern Lights and I'm like, I'm going to stay up late? Like, what do I need to look for in order to know if it's time to go out with my camera or time to go to bed?
Okay. So I personally use just this app only because I trust the real-time solar wind data which arrives at the... So it actually shows the data from a satellite which is between the Earth and Sun at a Lagrange point L1, and the satellite is called Discover. So it shows...
so that's like a stationary point in orbit, right?
Yeah, so it's like a stable point between Sun and Earth, so you can place satellites and instruments there. And so the app actually shows the solar wind velocity and solar wind density, then interplanetary magnetic field, and the south component called BZ of the interplanetary magnetic field. So when we want to decide whether we have to go out to see auroras, you have to see if the solar wind speed is high, especially like in terms of range. What you need to look at, it's better to have solar winds with above 400 kilometers per second, and you need to look for if the density is high. So if the density, also with density, it can vary. Even with less density, you can have amazing auroras. But what is the most important part in this is the BZ. You need to have a magnetic BZ in there, which is the south component of the magnetic field, which is being observed. And especially for Oslo, you need to have it consistently for like 30-40 minutes, the BZ negative, so that the aurora oval has the time to propagate towards Oslo.
Okay.
So, and it has to be as low as, say, -5 nanotesla to be able to reach Oslo.
And of course, it's got to be clear out, which happens. This is a problem for many aurora seekers, I think.
And one more thing which I want to mention, especially because, and I recently, like last year, I found that the weather cameras in Oslo and even in whole of Norway are quite good. So when auroras start to happen, you can actually see some north-facing camera. So especially the one here in Blindern, I use that to know if the auroras have actually reached Oslo. So you can even look for in the weather cameras for Hamar, which is facing north. And if the auroras have reached till there, you'll see them happening on the camera.
Okay. That's good to know, because I mostly just check my app and then I look at Facebook to see how many hundreds of people are posting about, should we go see the aurora? What's going on?
Yeah.
So what's the best time? What's the best time of night and what's the best time of a year to see the aurora?
So in Oslo, you can see, I have at least seen from August to April. So that's a pretty good range. Towards more north of Norway, I think it will be from October to March. Like the good season is considered October to March.
Okay. And do you have to stay out? Like, does it matter if you stay out to like 3 a.m. or something? Or is it just kind of any time during the night?
So it can actually happen any time. If the activity starts increasing from afternoon, you can even see, I have at least seen them even at 6 p.m. in the evening in Oslo. And sometimes the activity starts late at the night, so then you can see it at 11 p.m. or midnight. So it all depends how the activity and when the sort of the fast solar wind which we need for the auroras to happen reaches the earth. So it's best to follow the real-time solar wind data.
Okay. That sounds good. So, one of the things I really like talking with scientists about is not just what they're researching and the impacts of it, but just what does the life of a scientist look like? So, Monica, I want to go back to you first, and just what is being a scientist? You both talked about doing these campaigns and getting to do field work and stuff, but what does it look like to be a researcher studying Svalbard reindeer?
Well, it depends on the researcher you ask, I think.
Yes.
Yeah. But for most of my days, I just spend it in front of the computer.
Okay.
I work. So when we go in the field, we collect a bunch of data. We capture the reindeer. So that's only once per year. We capture them. We measure their body mass. We do some other biometric measures like leg length, and we count the number of antlers they have on their head. And we also check if they're pregnant. And then we also have a lot of instruments on them. So they're kind of technological, some of the reindeer that we work with. They have GPS collars, so they store positions so we can see how they move in the landscape. And what I've been working most with is something called biologgers. So these are tiny loggers that we implant into the reindeer just below the skin. And they record heart rate and temperature.
You say logger like an electronic recorder.
A recorder, yes. And they record heart rate and body temperature at a specific time interval that we program prior to implantation. And what I do when I sit and work with my data and do my research, I mostly analyze this type of data, right? I look for patterns in the reindeer behavior and changes in body temperature, variations in heart rate and things like that. And I try to make that make sense in relation to environmental changes and temperature and winter versus summer, etc. So it's mostly sitting in front of the computer and trying to make my data make sense.
Okay.
Yeah.
And sometimes going out in the field and wrangling reindeer.
Sometimes going out in the field. And then also, of course, every once in a while, it wasn't that much of it during COVID, but we do go to conferences sometimes, but that's more of once per year, maybe twice per year, where we share our research, we meet other people in the same field, but working in different institutions, and you share ideas. And I also do you also read a lot. I mean, you're never finished learning, even though I finished studying, I'm not out-learned, if that's a word. So I have to keep up with new literature, read what other people have been doing, find relevant papers, also scientific papers, published articles, things like that. And there's also a bit of teaching for most people, especially if you work at a university institution. You also have some teaching.
Yeah. Does the summers and winters, unlike most places people live in Earth, like, right, you have months of summer and then months of winter. Does that make it hard to work? And does it make your data kind of weird?
Actually, that's what I'm researching. So I'm researching the differences in in animal or the reindeer responses in summer versus winter. So for me, it's fantastic that we have this extreme contrast of continuous darkness for 4 months in the winter, and it's super cold, and the reindeer are just so sedentary. They're almost inactive. They have super low heart rates, super low energy expenditure.
It's like hibernating.
They aren't hibernating, but they have actually been coined like an Arctic almost hibernator, because they have this amazing reduction in their metabolic rate, so how much energy they spend, and their heart rates. You can see that they drop really low. So in the winter, they have a resting heart rate of around 40 beats per minute, which is like the resting heart rate of a super trained athlete, right? It's much lower than ours. While in the summer, this is adjusted to these extreme energy expenditures. So they're super active. They eat a lot. They try to gain as much fat as possible, and they have a very high metabolism. So then their resting heart rates can be up to 100 beats per minute. So it's this extreme change, and that's exactly what I'm looking into, and how these extreme differences actually translate into survival or better survival for individuals that have a certain level of response to these extremes.
Right? Well, sleeping just cozying up and sleeping all winter sounds actually quite lovely. But we had one of our speakers last year for the Science Festival talked about, or maybe 2 years ago for the Science Festival, had looked at how trees know when it's winter. And it was looking at like the is it the length of the day, up north, and so it's like is it the temperature, is it the timing, and that was their study. So how do I know they're not trees, but I assume there's something that reindeer, something triggers them. So is it that it gets much colder, or is it that it's longer days? Because at some point they're sort of even day and night, and then it gets longer. So how do they know when it's time to snuggle in for the winter?
Yeah, that's actually an entire field of research. Is how, not necessarily reindeer, but in general, how animals know when to change for a season. Mm-hmm. That is it's called you can call it timekeeping essentially, but it's the study of phenology, so changes in time. And reindeer, I don't know exactly, and I don't think anyone knows exactly what happens in the reindeer, but it's most likely a sort of internal, like their circadian clock, or not circadian because that's a daily variation, but it's a biological clock in them that tells them that by a certain point in the autumn, it's time to go from summer mode to winter mode. Mm-hmm. And it's a bit of a gradual change, but it's mostly by hormones that are the levels of specific hormones are changed in their circulatory system. So that's different hormones are released, and that sort of triggers these physiological changes and changes in their behavior. And but yeah, so what is actually determining when those hormones are supposed to be released? It could be light. It's definitely not temperature, because temperature is very fluctuating within the months as well. So it could be lights, but that's a completely different field of study. Yeah.
Okay.
So.
Okay. So Aditi, what does it look like to study the sun?
You mean like life, like daily,
yeah? What is the daily life of a solar physicist?
I think it's pretty much the same as Monica described. Mm-hmm. Like I am mostly in front of my computer, analyzing my data, trying to get results out of it. And instead of having campaigns in Svalbard, I have campaigns in Spain, where it's much more warmer. So we look forward to it. And apart from that, we obviously go to conferences and workshops. So.
Is there a particular reason why the telescope is in Spain? Is it like good for looking at the sun? Is Spain good for looking at the sun or something?
So it's actually in La Palma you have like a dormant volcano. So it's on the border. It's situated on the border of that, and the altitude is quite high. Mm-hmm. And so when you go there, you can actually see the clouds below it. So it provides very clear sky since it's at much higher altitude. So that's why it's situated in Spain, not here in Norway, where you mostly have cloudy.
Yeah, we have some clouds here, which again makes it a little hard to see the aurora. Yeah.
I can imagine if it was Northern Europeans that decided where to put this, they would have chosen Spain rather than Norway anyway, right?
Yeah, I think my impression is that Norwegians will take pretty much any excuse to go to Spain.
It's actually the telescope was started by it's actually called Swedish Solar Telescope. So it was started from Sweden and not Norway, but there are few countries which are part of it, so everyone gets few days to go. Yeah.
So you have you said you have some time. So what is that process like? How do you decide what it is you need to look at? Because you get a limit of time, right?
Yes.
So how do you decide, like, okay, we got 3 weeks, you got like this much time, like what are we going to look at? How do you make that decision?
So before going itself, we have like meetings where we decide whatever the observers are working on, who needs what kind of data. So we decide that from before. And then when we are there, usually the ones going prefer to have try to get the data they are actually working on. But if you have some solar flare happening, then we try to automatically point to that. And we are also coordinating with other instruments which are in space. So we also have to look what are they observing, so that there could be like coordinated observations, and you can have, so when you actually do the research, you have data from 2 or 3 instruments, and combining that is quite interesting.
Okay, cool. So once you do that, what does that data look like? I don't imagine you're just like getting a picture that you like
No.
look at, right? So what does that look like?
So we get like the size, at least the size is quite large, and and the data is actually in some cubes which we call La Palma cubes, since we are observing there.
Okay.
And then we can even change them to FITS format, which is like the standard format you have for any kind of observations, like astronomical observations.
Okay.
And then after that, we try to reduce the data, like make it in a form when we can actually do some research on it.
Mm-hmm.
So yeah.
And then so once you have that image, like what do you what sort of readings are you taking? You talked about magnet something, this magnetic spectrum. But what sort of things are you getting from that?
So at the SST, we have 2 main instruments, and they observe in various wavelengths. Like they observe in H-alpha wavelength, and then even calcium 2 NK, and we can even do polarimetric measurements where we observe the magnetic field.
Mm-hmm.
So these are the kind of measurements which we
right.
do
And then
there.
so the rest of the time, so once you have that, that's like a small part of your year, and the rest of the year is kind of like analyzing, figuring that out.
Yes.
What it looks like.
Yes.
Okay. Yeah. So when you're doing that, is there a sense of like how it connects to like a bigger picture of like the sun or physics in general, or?
So it's mostly to understand the sun more properly, because the data which we get there, as I mentioned before, it has very high resolution. So it's interesting to look at it, because for years you have, like for example, the instruments which are in space, they don't have that good resolution, and you don't see those fine magnetic fields which you can see the one which we get from the SST. So that's why it's interesting to look at.
Okay. And do you end up with cool pictures? Like I know everyone's probably seen like the James Webb pictures and Hubble and everything. Like, do you get cool pictures of the sun from that?
Yeah.
Okay.
So at the telescope there, we have like 6 big screens which show what we are actually observing. So when you start observing something really cool, we even pose with them and take pictures, because you see what's happening in real time at the sun. So
that's amazing.
Yeah.
Yeah. I mean, I've only seen like, photographs from the ground. Like I can, seen like an eclipse or something, and I have like my little lens, but I imagine seeing it from a telescope, especially a big telescope, must be a whole other experience.
Yeah.
So if someone is interested, like, both of you are doing really cool stuff, really cool work. If someone is listening to this and is like, oh, that sounds cool, like I want to see that, or I want to get involved in that, what sort of things can people do?
Well, I think it's, I don't know how you'd get involved in catching reindeer, for example, because that's a bit of a limited, experience. But I think if you want to, so reindeer, you can find them all over the Arctic. But in Norway, you have wild reindeer, which live in the mountain ranges, right? Quite a lot of the southern mountain ranges and the sort of inland mountain ranges in Norway. And they are very elusive. So I've never seen wild reindeer in mainland Norway. I've only seen domesticated reindeer. And if you want to see them, you're probably going to have to hike for a couple of days. And they are quite shy. So fortunately, ideally, we don't encourage people to approach them, because the wild reindeer in Norway are really shy, and you can easily scare the entire herd to run off.
But when you go for campaigns, do you actually go near the reindeers, or how safe is it then?
Yeah, so reindeer, they're not really aggressive, so that's good, or good for us. And reindeer in Svalbard are very different from mainland reindeer. So mainland reindeer operate in big herds, and they stay in the herd, and if they run away from you, they run away as one big herd can be hundreds and thousands of individuals. Whereas in Svalbard, probably because of the landscape there, and because the landscape in Svalbard are these huge, deep valleys and super steep mountains, so reindeer are very sedentary in these valleys. They don't migrate, so they don't move from one move across Svalbard, and they don't live in big groups. They only live in tiny groups or aggregate in tiny groups, like 5 individuals, and it's not really strict groups. So they can sort of switch groups whenever they feel like. So when we catch them, we just find the one that we want to catch, and then we have a snowmobile, 2 snowmobiles with a net in between. So the passengers of each snowmobile holds a net. It's a fish net, actually. It's about 7 meters wide and 3 meters tall. And we catch the reindeer with a net.
Oh, okay.
That sounds like I'm just imagining some sort of like Mad Max style, like hanging off.
It is kind of Mad Max style. It is like a cowboy meets Mad Max kind of adventure. And no one else should be doing that because that is for professionals.
Yeah, disclaimer.
Do not try this at home or in Svalbard.
Do you get any training for this, or you just...
Well, we train each other. So the people that started this project 25 years ago, they spent a lot of effort in the beginning trying to figure out how to best capture reindeer. And when they found this method that works really well, we've been doing the same for 25 years. So when I went there the first time, I got training into being one of the netters, as we call them. Whereas the driving skills takes a bit more years of practice. So we don't put anyone on this task. It takes a bit of training. But to get back to if you want to see reindeer, if you go to Svalbard, so the Svalbard reindeer are not shy, and they're quite easy to see because you see them all around. So if you go to Svalbard, you can even see them in the middle of Longyearbyen. So that's the settlement that you fly to. And you can see reindeer just grazing on patches of grass in the middle of the city, and you can walk straight past them and take photos of them. So they're quite easy to see. But in mainland Norway, if you want to see reindeer, you'd probably have to go to the north and see domesticated reindeer, because they are probably easier to spot if you see them out in the nature.
Okay, and from so that's if you want to see them at this point, what about someone who's maybe in college or before college, who's thinking like, this sounds like a really cool thing I want to study? Maybe talk about like your path a little bit and like what someone would have to do to, I guess, be like you and do this kind of research.
Well, you'd have to study natural sciences at some point, because it's mostly related to natural sciences. But it really depends on what you want to do. I think if you want to work in any, and this goes to any field of research, if you want to work on a specific topic, you reach out to the people that are already working on it and just say, hey, I want to do a master's. And if you get enrolled in a program at a specific university, you can still collaborate with people at other universities. So you just need to find someone at the university where you're at who's willing to help you work on a project outside of that university. So we are actually collaborating with students. We have master students on our project that are not connected to Norwegian University of Life Sciences, but we still help them, and they work with us on the Svalbard Reindeer project. So that's my best advice. Reach out to people who work on the topic that you're interested in. And most of us are quite nice and approachable. So. Yeah.
I mean, and is this something that like, someone who's an undergrad or even maybe in high school could get involved, or at least like reach out and learn more about?
Well, yeah, I mean, you could always reach out and learn more about it. We don't have that many researchers online, but we are working on making a sort of web page about Svalbard reindeer where we also highlight our research and update our research. But I think if you're a student in general, if you're a bachelor's or master's and you want to work on, like, do a student project, it's more than fine to reach out. That we have a lot of things we can work on, and we always find some sort of angle that a student can tackle if they want to. Yeah,
that makes sense. And see what how do people get involved or is there a way that people can get involved in any kind of like citizen science work or anything going on with your kind of research?
I don't know much about citizen science in terms of just solar physics, but at least for auroras, there's a project called Aurorasaurus, where people...
Is it Aurorasaurus?
Yeah.
Like the dinosaur?
Yeah.
Okay, that's an awesome name. Tell me about Aurorasaurus.
So in this project, what happens is that when people observe the auroras from wherever on Earth, they can report it to them, and based on their where it was observed, what kind of auroras was observed, they continue the research. That's based on mainly citizen science, based on the reportings of citizens. So that's happening with auroras. For Monica talked about approaching people for getting more into the field. even for me, I started out by, say, just taking physics as in my bachelor's and master's, and then doing summer internships to first get a feel of how the field actually is, and then you realize, okay, yeah, you can do research more on it. So that's the way, at least I entered in solar physics, and maybe even others can try.
Right.
Yeah.
Oh, that sounds wonderful. Yeah, it's always exciting to hear, because I know we have some younger listeners, and just people who are interested in this field in general, and it's always interesting to hear how people ended up in doing what they're doing. And I think a lot of times, to me especially, like, it's I hear about things like, oh, solar physics, like, how would you do that? Or like, how would you end up studying reindeer? And it's really cool. So it's really cool to hear kind of how you get there, and how maybe inspire someone else to get there. So that's about all the time we have. But I want to know if people want to get in touch with you or your research, how can they do that?
I have a Twitter account.
Yeah.
I don't have many followers, but you can sure contact me on Twitter if you want.
What is your Twitter handle?
It's Trondrud.
Okay.
So it's easy to remember. And also by email through my university webpage.
Okay.
I'm very active, or we always reply to emails.
Sure.
So
that's actually something I've noticed that I was very surprised about, especially when I was in like an undergrad. Like, you can just email a lot of these researchers and they'll respond. Like, most researchers, when I was doing research, and it sounds like you as well, like, it's exciting to get an email from a stranger and be like, hey, I heard about your research. Could you talk? Like, yes. So yeah, definitely encourage people to do that.
And I'm also on Twitter, so you can contact me there or from the email address mentioned on the university webpage. And my Twitter handle is _Aditi Bhatnagar. So.
Okay. Great. So thank you both so much for being here. I love hearing stories about science, about different kinds of research, especially research going on in Norway. There's so much cool stuff going on here. And to hear something is, kind of as diverse as, like, from reindeer and climate change to the sun and auroras is always really cool. So thank you very much. So that's going to do it for us. Again, I'm Matthew Davidson. We are Pint of Science Global Festival. It is May 22nd, 23rd, and 24th this year. You can find more info about that at pintofscience.no. We're also on Twitter. We are also still looking for speakers for this year's festival. So if you are interested, you can go to our site. Again, that's pintofscience.no. And there is a sign-up form if you or anyone is interested in being applying for one of our speakers. We can do that. And yeah, it's a fun experience. We go to bars. We have a couple presentations. We have a drink, alcoholic or not, and welcoming everyone. You get to hear some really cool science, like the science we just heard this afternoon. And again, huge thanks to House of Nerds for letting us use their studio. And again, to their guests, I'm Matthew Davidson. You can find me at MLD Sci Wizard on Twitter. And you can check out Pint of Science and all the other stuff we are doing through our website. So thank you again very much, and goodbye.
Thank you.